Hi, I'm Miranda Cosgrove, and this is Mission Unstoppable.
Coming up, discover the science behind testing car crashes.
I gotta say, you are crushing it out here.
And what can a sea slug teach us about neuroscience?
Look how cute they are.
Then, what is this cosmetic chemist whipping up?
It's a chemistry collab.
And meet a woman mining our ocean for renewable fuel. Get ready to meet the scientists, inventors, and heroes who help make our world a better place. The future is here. The mission, unstoppable.
We all want to make an impact, and some engineers do it by making an impact. We sent Big to find out more.
If you want to make cars, trucks, and SUVs safer, you need a lot of crash test dummies. And also a few crash test smarties. That's why today I'm meeting Becky Miller, a senior research engineer at the Insurance Institute for Highway Safety.
When I was a kid, I saw some of the very first crash tests on TV on the news, and I knew that was exactly what I wanted to do. I could combine my love of cars with my desire to do something to improve people's lives.
Crash tests are one of the tools Becky and her team at the Insurance Institute for Highway Safety use to make sure cars on the road are as safe as possible. Today, Becky's showing me how she engineers these tests, and I even get to see a collision live in person. Hey, Becky.
Hey, welcome.
Nice to meet you.
Yeah.
Now, were you one of those kids that like to smash their toy trucks together, or is that something new that you've just picked up?
I loved crashing cars. I had all these toy cars that I would build, and I would smash them into the wall.
You had to study engineering, though, to get here.
I did. I studied mechanical engineering, and I also studied biomechanics, which is the study of how injuries occur.
How do you engineer a car crash?
So we look at real-world data from actual crashes that are happening on the roadway. We can look at damage patterns, impact patterns, injury data from people, and find the trends, find the most frequently occurring situations, and then replicate those things in the lab.
Crash test dummies are some of the most iconic and important tools for crash safety engineers. In the dummy lab, these dummies are stored, repaired, and calibrated to make sure they are collecting accurate data, even after serious collisions.
We want to measure and understand what kind of injuries are happening to real people in crashes, and those injuries could come from all different parts of the body. A dummy could have anywhere between 30 and 200 sensors.
Oh, wow. What sort of information are you taking?
Displacements, so we can look at how far like a rib has displaced. We look at forces, so in the neck we have force measurements, and accelerations, so we can look at like G-force. This here is a side impact dummy, so all of the sensors are directed as if there is a side impact. In a front crash, many of the sensors are focused on an impact that you might see to the chest in the front, the head, all the way down to the tip of the toes.
And we got some shoes on this one. We don't want them running off, right?
Absolutely. Dummies are fully clothed and have shoes during the test. It's important to have shoes also because the foot is on the accelerator or the brake pedal, and a person driving would be wearing shoes.
That's true. Next, Becky shows me how they prep a car for a crash. Here they add high-speed cameras, lights, and sensors that track vehicle systems like brakes. Decals are placed to make sure the impact happens precisely where the engineers planned. Then the dummies are placed in their final seating positions.
We also paint the dummies.
We've got blue and pink.
This helps us identify what the dummy touches during the crash.
With the car ready, we move to the crash hall to watch the test. The regular lights are turned down. Special lights for the high-speed cameras turn on. And what's known as the crash machine tows the SUV into the impact.
So, what did you think?
That was incredible.
And look at all the damage.
Wild.
This front area can be as wrecked as possible, But as long as this area where people would be sitting in the car is left untouched, we know that it's protecting them. We also want to look at the dummies and how they're positioned in the seat. Do they look like they are well controlled? And the goal is to see only paint transfer on airbags. We don't want to see any transfer on like the steering wheel itself or the dash area in the front.
Right.
Within a few minutes of the crash, the dummies download their data to our network. We're comparing the videos to the data to get a more complete picture of what happened during the crash.
Nice.
These dummies also have a summary sheet that we get. Did the sensors tell us that the dummy would have an injury or not?
So what does this tell us for this crash?
The awesome news is that for both the driver and the rear passenger dummy, there are very low risks of injury for every body region in these dummies. We would expect that real people in a similar crash would walk away.
All right, so that's a good sign.
That is a good sign. It's a lot of fun to do these crash tests, but it's also really rewarding to know that the work that we do here saves real people's lives.
I gotta say, you are crushing it out here. High five for saving lives.
High five.
All right. When we pick our favorite animals, it's easy to just consider how they look, or if they come to us when you go. But what if we respected animals for their minds?
Every brain is beautiful in its own way, but some animals have brains that are truly special. And no one thinks more about brains than me, because I'm an expert on brains. After all, you might call me Dr. Brain. Okay, my real name is Crystal Dilworth, but I have a PhD in neuroscience, which is easier to call me Dr. Brain. So, I'm Dr. Brain! I mostly work with human brains, but humans don't have a monopoly on compelling craniums. So here are a few of my favorite non-human brains. Let's start with sea slugs. Look how cute they are. Evolution has taken a minimalist approach to their brain. A human brain might have around 100 billion neurons, but the humble sea slug gets by with like 20,000. Honestly, that just kind of sounds relaxing, like your brain just like running on low power mode forever. These little creatures have helped us understand key aspects of neuroscience. Their simple neural networks make it much easier to track how they store and transfer memories in response to stimuli. Not bad for a little slimy guy. Some of the most interesting brains are huge. Sperm whales have the biggest brain on Earth, with an average weight of 17 pounds. That's over 5 times heavier than our human brain. Whales have spindle neurons, which are only found in animals with highly developed brains, like some apes and humans. Studies suggest that blue whales travel to where they remember they found food in the past. And they all have complex social relationships and ways to communicate. Like whales, elephants are also carrying massive brains in their noggins. Theirs are around 13 pounds. They also have the special spindle cells that are so rare in the animal kingdom. They have more complex brain folds than us, and like humans, elephants can play, use tools, communicate, and even grieve for their loved ones. They also have a large hippocampus, which could help them store and recall long-term memories. So whoever came up with that whole "an elephant never forgets" thing really was onto something. But does bigger always mean smarter? Another one of my favorite brains in the animal kingdom is a little one, and it belongs to the corvids. Crows, ravens, and blue jays all show signs of intelligence despite their size, with some scientists suggesting that crows are as intelligent as apes. They can recognize the faces of individual humans, use tools, and even solve physics puzzles. Some scientists even think crows show signs of self-awareness and consciousness, not unlike humans. But of course, my favorite brain in the animal kingdom belongs to us. I'm not just biased because I am a human. Even the corvids would have to acknowledge the incredible abilities of the human brain. Think of the great Cathedral of Notre Dame, built over 300 years, with different artisans and laborers working on a shared vision for generations. That kind of communication and imagination is what makes us so unique in the animal kingdom. So even though we can't fly or swim the ocean's depths, we can build cathedrals and host TV shows. Humans are still on top, baby. Bye.
Soap might seem like a simple technology, but this next guest is really raising the bar.
When washing your face, you want to use something that'll really clean your skin. My favorite cleansers are foaming cleansers, and today I'm going to show you how I make them. Hi, I'm Amanda, a professional cosmetic chemist, and I'm here to teach you what goes into some of your favorite beauty products. Cosmetic concoctions with Amanda, yeah! Every ingredient we use in our formulation plays an important role, but the one I want to focus on today is the cleansing agent. Cleansing agents are not tiny little secret agents who clean your skin for you, but that'd be pretty cute. In this formulation, we're actually using 3 different cleansing agents. It's a chemistry collab. They have really long names, but if you must know, we're using sodium C1416 olefin sulfonate, sodium cocoa glycinate, and sodium lauryl amphoacetate. Not only are these cleansing agents found in our foam cleansers, but they're also found in shampoos, body washes, and hand soaps. In addition to adding the foam and lather to our cleanser, these cleansing agents actually work by removing the contaminants from the skin, which leave the skin nice and clean. They're super strong, so they're able to cut through dirt and oil better than just water. When we're making formulations, we separate our different steps into phases. These phases are determined by what ingredients need to be processed together. If we process the wrong ingredients together, they won't work the way we need them to. Like imagine making a cake and adding the eggs after it's been baked. Ugh. To make our foaming cleanser, there will be 2 phases. Let's start with phase A. Safety first, gotta get our gloves on. To get this going, we're going to need our first 2 cleansing agents, sodium C14 olefin sulfonate and sodium cocoa glycinate. We're gonna combine these into our beaker, then add water. We'll mix it until it's fully combined. I like to pretend the little stir thing is sentient and it's in there just like... Now it's time to get into phase B. We're gonna take our last surfactant, sodium lauryl amphoacetate, and add it to the beaker. Scrape, scrape. Next, we're gonna add in our preservative. Drop, drop. This will essentially help us extend the life of our cleanser and keep it from growing any harmful bacteria that we don't want to spread on our skin. Sorry, harmful bacteria, I hate you, and I'm not afraid to say it. Next, we're gonna add a little bit of fragrance. I'm using jasmine, because it's my favorite. This is a water-soluble fragrance, so we don't need a solubilizer. Normally, fragrances are oil-soluble, but because this is a water-based product, we use water-soluble fragrances. Just makes it a little easier. Now that our phases are mixed together, we want to make sure the pH balance is correct. We don't want the product to be too acidic or too alkaline for our skin because that can lead to issues like dryness, irritation, and acne. I'm going to test the pH level with my pH meter. We're looking for 6 to 6.5, so I'm going to add some citric acid. Citric acid is really acidic, so it's going to bring down the pH of our product, and that's going to help us get to a more neutral skin pH. Now that we have our pH balanced, we're ready to bottle up our cleanser and test it out. We're gonna put our cleanser into our container here, which makes it nice and easy for us to get the perfect amount of cleanser with each pump. The pump on the container is very important because it combines our cleanser with air in order to create a nice foamy face wash. I knew air was gonna be useful for something eventually. This feels great on my hands, and I can't wait to feel it on my face. And this is gonna keep our skin nice and smooth and clean. And who knows, maybe our skincare is really the cleansing agents we met along the way. See you next time for more Cosmetic Concoctions with Amanda. Bye!
Some people see seaweed and just see a weed in the sea. Others see seaweed and see the future of fuel, like Diane Kim.
Giant kelp is vital to the ecosystem of our oceans. And you probably think you don't even know what it is. But if you spent any time at the ocean as a kid, you definitely dressed up in it. Look at me! I'm a kelp mermaid!
Giant kelp forests help clean our coastal waters, provide habitat for ocean animals, and they might just help combat climate change as the source of a new generation of biofuels. And that's where hero scientist Diane Kim comes in.
I personally love being around the ocean, and so to be able to do that every day for my job is a dream. Looking at kelp as a potential source of biofuels, something that could potentially revolutionize the energy landscape one day, I mean, is an incredible feeling.
Today, I'm on Catalina Island off Southern California, where Dr. Kim is going to show me the incredible technology she's developing to protect kelp.
You're a biological oceanographer.
That's right.
But you decided to focus specifically on giant kelp.
Yes.
Why is that?
They're really important for marine ecosystems and for our planet, frankly. It sequesters carbon dioxide, it produces oxygen, it creates a habitat, food source, nursery grounds for so many marine species. So you can actually turn kelp into an oil that you burn for energy. You don't need fresh water, you don't need fertilizer, you don't need land, and you have so much space in the open ocean.
Is this biofuel better for the environment than, say, fossil fuels?
Way better than fossil fuel. You are creating an oil that you burn, and so you're emitting carbon into the atmosphere with kelp biofuels.
Yeah.
But that carbon is about the same carbon that the kelp sequestered from the atmosphere to build more of its biomass in the first place.
So it's emitting carbon, but it's also taking it back in. The kelp.
Regenerative, renewable, exactly.
That's amazing.
The amount of giant kelp growing in our oceans is declining due to human activity like coastal development, fertilizer runoff, and especially climate change-induced sea surface warming.
Warmer sea surface temperatures are generally associated with lower nutrient concentrations.
Oh, really?
Without nutrients, kelp can't grow.
Once the kelp is collected, Dr. Kim takes the samples back to her lab at the Wrigley Marine Science Center. Inside the dark patches of these special blades called sporophylls lies the next generation of giant kelp.
Kelp, even though they're referred to as the sequoias of the sea, they actually start off no bigger than a large bacterium. So the spores are about 5 micrometers in size.
Wow.
And they swim. They have 2 flagella, and they swim around until they find a hard substrate that they like.
Dr. Kim cleans off the kelp tissue to avoid contamination, removes the parts she doesn't need, and places her sample in a beaker with nutrients to stimulate the release of spores. After waiting a bit, she grabs a sample, and it's time for the moment of truth. Do we have baby kelp?
We have spores.
We have spores.
There are a lot of them, and they look really healthy. They're swimming. They're really zooming through the water.
With confirmed spores, we're ready to pour them into this special tank where they will attach to their new home. This spool of twine around a plastic pipe.
Once they get to about 2 to 3 millimeters in size so that you can see them with your naked eye, then we take this spool of twine and we take it out into the ocean and we unspool it so that we can grow it on long lines.
You go, spores. Find your home.
So they'll be in this nursery tank for about 45 days before we send them out into the open ocean.
Enjoy your new home, spores. But this is truly amazing, and I know it's gonna take a while for those spores to grow, so just let me know when my babies are all ready for me to see.
I definitely will. And you know, one day when we're both pumping kelp into our cars, we'll remember this moment.
Thanks for helping the kelp so the kelp can help us.
Welcome back. Before we go, we have one last thing.
Find something that you're passionate about and figure out a way to turn that into a career. Look for the science in that passion. Science is everywhere, and find a way to turn that into a career.
That's it for Mission Unstoppable. I don't know what we have coming up next week, but maybe it's something on mirrors. I could see myself working on that. Bye. If you're watching this, you must have really liked the video. Make sure you follow and subscribe, and check out these other videos that are even better. No, really. I've seen this one over 100 times.